Assalamu alaikum students, hope you are all fine. Today's our topic is about mean value theorem. It is the most important theorem in calculus. So before discussing mean value theorem, we will start with Rolle's theorem, which provide the sufficient condition for the existence of critical numbers. Now the Rolle's theorem states if f is a continuous on a closed interval ab and it is differentiable on the interval open interval ab and the endpoints of the function f of a is equal to f of b, then f prime of c is equals to 0 for at least one number c in the interval. So here we sketch three different type of diagram, and from these sketches we expect that there is at least one number c between a and b such that the tangent line at the point c, f of c is horizontal, that is f prime of c is equal to 0, which is precisely the conclusion of Rolle's theorem. Here you can see in this diagram at this point C is lying, then there is the tangent line is horizontal, and like in this diagram at this point if f of c is equals to 0, f prime of c is equals to 0, then the tangent line is horizontal. And in this diagram here we will be have any point c at which f prime of c is equals to 0, and here the tangent line is horizontal. So we have an example in which we will apply Rolle's theorem. Let f of x is equals to 4x square minus 20x plus 29. Show that f satisfy the hypothesis of Rolle's theorem on the interval 1 and 4, and find all real number c in the open interval 1, 4 such that f prime of c is equal to 0. Explain graphically. Now the first one, this diagram for this function, we will plot the value from 1 to 4, and according to 1 and 4 we will have different values, and then we will plot these values graphically. Here this is the diagram of this function, which is like parabola. Now for the hypothesis of Rolle's theorem, it must satisfy that f must be continuous and differentiable for every value of x. Now since you can see that this function is a polynomial function, and polynomial function is always continuous in its interval, and it is differentiable in the given interval. Now for the third point, for f of a is equals to f of b, here for f of 1 it is 13 and for f of 4 it is 13. So we have the same values for the endpoint of the function. Thus f satisfy the three hypotheses of Rolle's theorem on the interval 1 and 4. Now differentiating f of x, f prime of x is equal to 8x minus 20. By setting this f prime of x is equal to 0, we will have x is equals to 5 by 2. So f prime of 5 by 2 is equal to 0, and this 5 by 2 is lying between 1 and 4. You can see that it is here. 5 by 2 is here. Now the graph of the function is parabola. Since f prime of f by 2 equal to 0, the tangent line is horizontal at the vertex 5 by 2 and 4. So this tangent line is horizontal here. Now then we will come to another theorem, which is your mean value theorem. Now for mean value theorem, the first one condition is same like Rolle's theorem, that f must be continuous on a closed interval ab and it is differentiable on the open interval ab. Then there exists a number c in the interval ab such that f prime of c is equal to f of b minus f of a over b minus a, or equally it can be written as f of b minus f of a is equal to f prime of c times b minus a. Now we have an example, which is f of x is equals to 1 over 4x square plus 1. Show that f satisfies the hypothesis of the mean value theorem on the interval -1 and 4 and find a number c in the open interval that satisfies the conclusion of the theorem. Illustrate the result graphically. Now for graphically, for the explanation of graph, we will have the table of the values from -1 and 4, and according to this table we will draw a diagram. Now the first one condition for continuous function is now that this is quadratic function. So as you know student, that quadratic function is always continuous on the interval, on the given interval, and it is also differentiable in the given interval. Now we will, for mean values theorem, which is f of b minus f of a over b minus a is equals to f prime of c, using f of 4 is equal to 5, f of minus 1 is equals to 5 by 4, and derivative of the function is equals to 1 by 2x. Now putting these value in this mean value theorem, it will be c equals to 3 by 2. If we solve it algebraically, it will gives you the value of c equals to 3 by 2. Now the endpoints of this given function is p minus 1 and 5 by 4 and q 4 and 5 corresponding to the given interval. We will draw a secant line combining these endpoints, and the given value for the critical value c 3 by 2, its function value is 25 by 10, and it is the point at which the tangent line is parallel to the secant line p of q. It is your secant line p and q, and it is your tangent line which is parallel to the secant line. So then we come to the exercise.